Hello, everyone. We have some people appearing, quite a few already. It's wonderful to have you with us. We have some familiar names we've met before. We have some new names. And everyone who is new, welcome. Thank you for being with us here on this lovely summer day, especially if you're from Moscow, where the weather is especially lovely today. It's almost time to start. And as usual, we like to start on time. In fact, it is time to start. So let's go ahead and do so. Those of you who are here for the first time, feel free to introduce yourself in chat or in Q&A and tell us where you come from. My name is Valentina Kuskova. I'm an academic supervisor of a program that's called Master of Data and Network Analytics, for those of you who haven't met me before. Now, today we're talking about managing your relations, particularly the data relations. Why do I, as a supervisor of a master's program on applied analytics, think that I'm qualified to talk about managing your data relations? Well, because data analytics has everything to do with data relations. It starts with data relations. It starts with data. And over many years of analyzing data and a few years of supervising this master's program, I have learned that very few people can do so effectively. It's interesting because lots of people assume they know how to manage their data. They know how to work with files. The only question I ever get asked is, well, do you teach SQL? Of course, I know SQL very well. In fact, that was one of the first programming languages I've learned when I first started to work in data sciences, let's put it this way. Lots of people have different terms for that. It was the very first language I learned. I worked with Oracle database using SQL, and I was working as a programmer for a large Fortune 200 company in enterprise applications division. So a lot of work that I did was SQL. I've never really saw my data. My data was stored somewhere on the large server, but I executed lots of commands and I executed queries, which I then delivered to people who requested them. That was the work I did. I did some database programming. I did that with a specific software called Fourth Dimension. I still think it's the best software. It's been bought out since then. It's still in existence. So if you're looking for a good database to work with, give it a chance. But the story goes like this. When I started working with data, I never really knew what happens with my data after I send it to my customers, people in the company who requested it. Well, time has gone and I started becoming user of that data, and I've realized how much of a disconnect there is between data that's pulled off the server and data that end up being analyzed. So today, let's talk about managing those relations. And I will talk about simpler things or beginner things that many of you may think that you know very well. In fact, I will make a caveat. I'm sure many of you know these things, but I will structure them in a way that you can see the connections between the data you are using and the data that other people are either using after you or other people who generate that data for you. And we'll see what are some common problems and how you can fix those common problems. Now, lots of times when we start our webinars, I ask you a question. How good are these data files? I'm going to show you a data file that is actually a very dear data file to me. Well, in fact, you can see from the title, it's called Dissertation data. So this is the file from my own dissertation that I have defended at Indiana University. And here I'm looking at the table that appears to be correlations. It's just opened on this particular tab. I'm not even sure these are correlations judging by the diagram, right? So I have this tab that's called full data set, okay? Apparently, the first row is the variable names, and then I have some data throughout. This is a very large file. Okay, it's taken me, well, you can see looking up over here how many variables I have in it. A lot of, there are lots of zeros, there are lots of empty rows, empty columns. It's a very large file. So if we were to look at these dissertation data file with these variables, what would you tell me about how good is this particular data set? Talk to me. You're the user of the data. How good is it? Don't tell me you don't know variable names. That's obvious. Let's pretend we know variable names, okay? So assuming we know variable names, how good is this data set? Anyone? Somebody? Don't be shy.
I can start actually. So actually in the number 2906, 2907 and 2901, they have only zeros as I can assume. And probably
it has an average of 0.13, so it has some ones in there.
Okay, it has some ones, so so maybe it has a lot of zeros, and we can understand what is it. Or also, it's also one scale, so it's from 0 to and the maximum of the scale was number 2. So I think the scale are standardized in some way. For example, and maybe there is a good data.
Okay.
Also, some people write in the chat that depends
yes,
how many.
Yes. I am going to go through these comments and address them. Okay. So here is the comment from Anastasia. Depends on how many missing data points there are there. This is an excellent comment. I'm glad that you have noticed this. As I'm showing you these files, there are some variables that are obviously non-empty. You can see there is an average here. The sum is 19, count is 36, 18. So this variable has some values. Okay, here's a 0. The problem with this particular variable is that it has what appears to be missing data, lots of missing data. And next, what I see over here is there are variables that don't have missing data. So what is the problem with this particular file setup? Now, I know this now. I did not know this when I was working on my dissertation. It has taken me years to acquire this knowledge. The problem is that even missing data have to be coded somehow. Missing data have to have a code, let's say 9999 or something else that you can later programmatically extract out of your data set. The problem with not coding data as missing is that lots of software packages do list-wise deletion of missing data. So I might have a perfectly good record, but I have just one cell missing right here and the entire record is gone. Or I might have, a good record otherwise. I have every variable over here that I need, but then I pull in one of the variables, let's say this one, V105, to say, hey, I wonder what this variable does to my data. And I'm going to lose all this information because there are lots of missing data points that do not have any coding whatsoever. Lots of times when that data are being read, those records are being deleted. So that's the first very good question. There is no subject ID. This is actually a very good assumption. There is no subject ID. In the original data file, in fact, this is a data set from a data set called Americans Changing Lives. There are now 6 waves of data collection. I had the first 4, so there is an excellent code book that contains all the metadata that could possibly be necessary for that data file. It's been going since 1986. I believe the latest wave of data collection is 2018. This is probably one of the richest longitudinal data sets I've ever worked with, given its size. It has thousands of respondents. So the code book is good, and there is a subject ID. It's not in this data file because for me, it wasn't important. I wasn't doing subject-wise analysis. I was looking at the overall averages. Missing value is the main problem. The rest is clean. Not clear if 0 is missing or an actual value. Another excellent point. For example, here I'm looking at the V9. I used to know this data set very well. I knew what every single variable meant by heart. After you work on your dissertation for a while, you memorize those things. Guess what? I don't remember now. So when I'm looking at this V9 variable, is this 0 as 0 or is it a missing value? I have exactly the same question. Now, I do not know now. I know which variables I have used for the data set, and those variables were clean, but originally when I'm looking at this, I have no idea. Also, I have this very strange column that raises questions because see how I have some high values and then I have ones. What do the ones mean? All right. Can existing data be used for missing values? This is an excellent question. And missing data analysis is a very complex topic that requires not just a separate webinar, it requires a separate probably class. In our master's program, when we teach contemporary data analysis, we talk extensively about state of the art in missing data analysis. And there is maximum likelihood procedures, imputation procedures that are superior to others, but it's a separate lecture altogether. Here's another one. We draw limited conclusions only based on the data that's full. The absence of certain values in the table might not be an issue. Correct. This is an excellent point. When we draw conclusions based on some data that are available, if we do not use, first of all, if we don't use variables that have missing values, that's not a problem. Second, if our missingness is what is called missing completely at random, then we can probably deal with our data set and with values that are present only as if they are missing at random, as is with the entire data set. But I would say that I'm going to, it's mostly talking about missing data here. Knowing what I know now, I see many, many more problems with this data set that I will return to throughout our webinar. And I just want to get our thoughts going and talk a little bit about why are we talking about managing data. One thing, again, this is empirical observation that I have acquired over many years of working with data and teaching students, is that lots of times students do exactly what I did when I was defending my dissertation. They did not keep clean notes. They did not analyze the structure or record the structure. For example, here's a tab, data weighted. There is a comment used, which means I used it in my data set. And here are some colors meaning something that now looking back at it sometime later, I can only hope I kept good notes because I have no idea what all of this means. Plus there are lots of other colors here. So and I thought I was good at data management, okay? Because by that time I was already a good student of statistics and a good teacher of statistics also, I thought, okay? So I would say that the data files I have shown you are no good for many reasons, and some of which I will return to throughout the presentation. So thank you for talking to me. You guys were good and you've made some excellent observations, which I think is delightful. All right, so today, I will introduce myself briefly. I'll make some important announcements about our master's program. We'll talk about the data issues, tasks, and competencies. This is a very important point because lots of people brush that point off. Again, as an academic supervisor of a master's program, I often get questions about data or databases that are framed in, do you teach SQL? Well, I want to say that almost anyone can teach SQL. Almost anyone can learn SQL. Knowing how to manage data before and after SQL is a much, much harder problem. Okay, so we'll talk about that. Then next, we'll talk about raw data and coded data. And databases store data. SQL pulls data. Databases, no matter how good the engine is, are stupid. They only do what you tell them to do. So if you enter data wrong, or if there are problems with your raw data, then you're going to have problems in your database that no SQL can fix. We're going to talk a little bit about data files and cleanup. And then, of course, I'm going to talk about our master's program, which is a one-stop shop for all skills related to data management, which we teach lots of data analytical techniques, a lot. You can see from the information on our website how many subjects we teach. With that, those analytic techniques are only 5% of what you do with the data. The rest 95% have to do with data cleanup, storage, coding, and all other data manipulations that we have to do before we start the analysis. So let's talk. This is me, and many of you have already seen me before. I define myself as a social data and network analyst, first and foremost. I'm the founder and the current head of, Master of Data Network Analytics program. I was also the founder of Applied Statistics with Network Analysis program, which is our offline programs. We lovingly refer to them as MAZDA and MDNA. Of course, for people who have never seen those abbreviations, they mean nothing. To us, they mean mirror image programs of each other. Mostly, I talk about Master of Data and Network Analytics program, which is MDNA. Even though content is the same, the method of delivery is different. And since I'm talking to you here online, most of you are probably, if you're looking for some education, are looking for online education. So this is the program that delivers state-of-the-art data and network analytics for insight discovery, prediction, and prescription in modern decision-making. This is our motto. So MAZDA is an offline program that has been opened now 5 years ago, had several successful graduate cohorts that I can talk and boast a lot about. So I suggest we don't spend too much time on that. MDNA is its mirror on the Coursera platform. So that is pretty much the only difference. If you want to study offline and live in Moscow, Russia, I suggest you apply to our MASNA program. If you want to live in the comfort of your own home, even in the Moscow area, and studying at your comfort time, whenever it is convenient for you, then online version is better for you. Otherwise, both programs are containing three major parts. Applied data, and it's an important point talking today especially, we're talking about data that are live, that came from real-life companies, real-life projects, real-life experiences. We can simulate our own data. In fact, in some of the courses, simulated data are essential. For example, when we're running exponential random graph models and we're doing goodness of fit diagnostics, and when we are running Bayesian simulation, we need the Metropolis algorithm requires lots of simulated data. But in real life, we analyze real life data. So our program is focused on real life data. Second important component is networks data, because our program is one of the few in the world with a focused delivery of network analytic tools. Lots of people talk about graph theory. Lots of people talk about how to calculate centralities. Not very many programs teach an entire range of network analytics courses or network analytics instruments as we do. And for those of you who don't know what a network is a structure that's created out of a very different type of data. For any analysis out there, the unit of analysis is one data point. So it's just one unit. You can look at one and describe it. Let's say you take an apple, right? And you can describe an apple, that's your data point. For network, you will need to have an apple and an orange, because it requires two data points and the possibility of connections between them. Even that connection is zero, or what we call a null dyad. So special type of data that's called network data is analyzed on a dyad level at least. And then we combine all of that data into state-of-the-art analytics that we modify every year to make sure we respond to the demands and challenges of outside world. Our program is very flexible, designed to tailor your specific needs, because we realize that you come from different backgrounds and you have different expectations of the programs that you want to study at. So because there isn't really a range of programs for every expectation, we decided to incorporate them into our program. So we have different levels where you can start from scratch, start from zero, and take then advanced topics. We also have a large choice of courses. If you want to study Bayesian analysis, you can. If you want to study machine learning, you can. So there is a wide range in between. And we do have worldwide recognition that comes from the community, from the academic community, in terms of our students being accepted into top world's programs such as Manchester, Bristol, and Oxford for their PhD studies. In terms of academic community, not academic business community, we have our students win Kaggle competitions, which is of course worldwide and open to everyone, against other data scientists, data analysts throughout the world. So if you want to find out more information, it's a relatively standard URL, and I will send it to you in the chat. HEC EN, that's for English language, MA Data Analytics. And if you want to take a look at the courses we teach, there is a free Coursera specialization offered on the Coursera platform, where we offer 4 different courses: contemporary data analysis, network analysis, which is just an intro to text mining with R, and business analytics. The reason why there is text mining and all of that is texts as the source of data are going to blow up in the next couple of years, just like big data blew up, right? Just like data science is a buzzword. Watch it. Text analysis is coming to our world, whether you want it or not. So I suggest that you get ahead of the curve and learn these instruments now. All right, that's the link to our specialization. Now, there's, for foreign citizens, the application deadline for both of our programs is August 10th. There is only a week left. So make sure you get your documents in on time so you don't miss out the chance to become our first cohort of MDNA students. For Russian citizens, it's a little bit longer, but still not much. And apply now to avoid delays. And of course, you can write to us with any questions you have. mdna@hec.ru will get you there. With that, let's talk about data. Have you ever thought about where do the data come from? When a company presents a report, for example, we just presented a very large report on Russian automotive industry, state of affairs, and the socioeconomic impact that was commissioned by the Association of European Business. It was a large and broadcast presentation for, well, it was a media event. And quite a few questions were asked. Nobody asked the question, where did you get the data from? In fact, we've had many of these presentations, and lots of times the data question was prepared for the backup. Hardly ever wondered what were the data that we used. Or when you're studying certain tools and certain programs or certain instruments of statistical analysis, you have lots of computing examples. Have you ever wondered where do they come from? So when data are in the form that you can use, it means that someone, somewhere, somehow, at some point in time, has turned raw data that's available all around us into a form that you could use. So the question is, who was that person? When and how they created that data? Where did they get it from? Because data don't come in nice, clean numbers and spreadsheets, right? They come in the form of what's around us, and we measure it somehow. So who and measured what to get you that data? This is a very important question that lots of my students over the years were never aware of. And that generates the biggest problem of them all, because as I often say, junk in, junk out, or garbage in, garbage out. If you have bad data, you'll never have good results. That's just simply impossible. So that's the first question. Whenever you do your analysis, that you should ask yourself, where do my data come from? Now, there are common data issues. First of all, is building and maintaining it. Now, lots of people think of database as an important, or database management as an important tool to have. I want to emphasize that a database is a place. Well, I mean, not necessarily a physical place. It's a place somewhere in your computer storage where the data are stored in the form of zeros and ones. But how did it get there? The data, how did it get to that storage place on your hard drive on some big server out there? The question of how data get there, that was never asked of me either. So database management is much, much more than simply storing the data and getting it out through SQL calls. It's also getting data into the databases, and before that, assuring that data quality. Now, the second data issues is working with data that come in unfriendly forms. For example, when we did our first report on socioeconomic impact assessment, that was Laboratory for Socioeconomic Studies led by HSC First Vice Rector Vadim Radayev. We were not very experienced. We asked the company to just give us the data dump and we would figure it out. They gave us the dump that contained 7,500 files, 7,500 of different quality, size, timestamps, contents. It was a mess of 7,500 files. That was the most unfriendly form I think I have ever seen. But imagine you're working in a large company. You're going to have those data dumps daily, okay? And how do you move beyond conventional data sets? That's an advanced question that many people don't even think about. What is a conventional data set? And by contrast, what do you think of as unconventional data set? Now, in practice, these common data issues translate into coordinating data collection. Lots of companies struggle with keeping, maintaining, or even developing databases that are useful for the purposes. Especially when it comes to getting data from separate locations or from separate parts of the company or several departments, separate departments that store data in different formats. Yes, I know enterprise applications now offer a variety of solutions for data storage, for example, from the point of the customer entry into the system to the point of employee getting paid for the work they did for the customer. Guess what? None of these enterprise systems are good enough. They have lots of positive qualities, but they're not good enough. They have lots of issues. When you understand those issues, you learn how to work with them. Now, mining data for new information and insights. Imagine you are running a company and your product is not selling. Your data will contain an answer to a question why. The data have all of that information in it. Where do you even start looking for it? How do you find that answer? And the problem is that coordinating data collection, assembling data, or mining data, those are buzzwords. And they really become issues that mask fundamental problems. Lots of times students ask me, well, do you do data mining? Yes, we teach data mining. Just you have to think of this process as an integrated process where lots of things have to come together and come together correctly in order for data mining to work. So I have to say at our program, we do teach this integrated approach where we take everything from start to finish so that you can have that broader view of what goes into data analytics. And as I often say, you will never think about data the same way after you're done with our program. Now, there are lots of hurdles to the high quality analytics. So we don't just start with analytics. We have to talk about how do we make it high quality. First of all, if you have to depend on others to prepare data, you're in trouble. That one person makes a single careless mistake and you are done. This is not the time right now, but I often tell my students a story when the written paper, completely written with wonderful insights and lots of work put into it and lots of time spent on analyzing data, and a paper that was supposed to make a breakthrough. Well, you don't see my name as someone who made a breakthrough, right? Because all of that went to a trash bin because the paper was not salvageable. We were working on hard power versus soft power, and the student was using, well, not even student, an assistant was using a secondary data set that contained lots of tables and lots of columns with data. And instead of using the measure of hard power, such as usually military or some other similar resources, they accidentally pulled in a column that contained the amount of corn sold. So we spent almost a year analyzing data, writing up paper, doing theoretical foundation, everything else for corn, okay? So when you depend on others, you could be in trouble. Sometimes people assume data management is not crucial. Nothing can be further from the truth. Data are everything. So you have to make sure you carefully work with that. Another caveat that I often fail to mention, but I will say to you today because it's so important, long stops in projects. When you work on a project and you stop on it and then you don't work on it for a long time, you won't believe how much you forget. And that's a major source of errors, simply because you forgot making assumptions. And another issue that we struggle with the most in academia, but even though it's present in practice, is dealing with computing issues when you have to calculate something at the same time as you are dealing with conceptual or theoretical issues, as in, what does this even mean, right? So before you start adding it all up, figure out, what that means. Now, in terms of data management tasks, so when you're actually starting to develop your data relations, right? We're talking about managing your relations. First of all, you have to find out your data sources, your potential data sources. And an amazing issue that I often come across is that as soon as people find one data source, one data set that contains information they want, they're done. They say, well, I have this, let's say, data set that's called quality of governance. That's a well-known data set in political science. This is an excellent data set, I'm done. My question often is not only about the quality of data. That part is even aside. My question is, are you sure you have checked everywhere and some other data set out there does not have something better that is better suited for your needs? So make sure that you learn a variety of places where data are stored and pay attention to when papers are published, where do authors get the data from? An excellent, of course, is the Harvard Dataverse, an excellent repository of secondary data, Stanford repository, and lots of major universities. Michigan has an excellent collection. So start creating your own database of data sources and check them out frequently because they do get updated. Now, new sources, especially those that provide data in computer-readable formats, people still ignore GitHub and some other similar sources. Those are excellent places. Don't forget about those. Now, another issue, another task is preparing data for use in some kind of an analytic program. Lots of times there is no direct one-to-one translation from one program to the other. For simpler problems, you can easily use R for conversion, but lots of times there are issues that R is not capable of detecting unless you do some specific analysis. For example, we're in Russia, we use a Cyrillic alphabet, and Cyrillic alphabet has different character numbers for the same looking letters as Latin alphabet. For example, this letter A in the tasks, this could have been written in English or in Russian, and you wouldn't know the difference. Now, when you translate the textual data in R from one format to the next, you may not know that. So R will not detect that, it will just move it over. So preparation for the analysis is something that lots of people take for granted. We have a special course that's called Exploratory Data Analysis that allows you to learn how to deal with those issues. Now, working with computer programs on how to interpret the data, that's a data management task that everyone eventually learns, and it's not that difficult. So I'm not going to spend too much time on that. Now, restructuring your data. when you already have an existing data set and you want to put your variables together differently. For example, you want to calculate an index of some kind from the variables that you have. That takes specific skill. And again, lots of people take for granted the fact that they're capable of doing so. I will give you a very simple example. Let's say, take a measure of your customer satisfaction. For example, how satisfied are you with a service of your internet provider? On a scale from 1 to 5, you can answer 5 questions. I like the service provider, they're timely, they provide excellent, their response time to complaints is excellent, they have very quick customer service, and I'm satisfied with the speed of my internet connection. I dare you to create one measure. How would you combine these 5 questions into one measure of overall quality of this company? Will you average the scores? What would you do? Would you build a factor analytic score of some kind? So immediately you start realizing that it's not that easy to restructure data. I wasn't expecting answers. If you attempted to answer, I'm sharing the screen, I can't see that, but maybe Anna can help me. So see how not intuitive some of these things are. You have to have information about how to do those tasks before you can actually take on that daunting job. I will not go into the details about the fact that when sometimes you have existing data and you need to supplement it with new. As I said, my dissertation was written when there were 4 waves of Americans Changing Lives collection. There are now 6. If I want to analyze my data, how would I do that? How would I go? Of course, there is a customer or respondent ID, and I can do the respondent ID-wise addition, but how do you actually do that? What's the actual algorithm? Would that be easy? Would that be hard? Now, if you generate your own data, providing documentation assistance for others is an important task. One way to do that is create a metadata or made a file with metadata that describes every single step you do to your data. If you color something in a certain color, you have to make sure you explain why you do that. Now, make sure you back up your data and create multiple versions. You absolutely must back up your data and create a new version out of every single change to the data. You've changed one column, back it up, make a new version, note what you did. You've replaced missing values, back it up, create a new version, write what you did. So if at any point in time you have made a mistake, you can go back to the latest, the newest, cleanest version, right? The one that does not have mistake, and then keep going. If you make several steps to your data and then make a mistake, good thing if you have a copy of your data, you can go back and redo those several steps. But it's much easier to create versions because you might need those versions for different purposes. And of course, learning how to integrate different sources, formats, data files, etc. That goes without saying. But I would say that start thinking about data management as a separate skill, as a process. So for yourself, create the process of working with data so that you can avoid problems in collection, storage, management, that if you take a long break in the project, you can come back to your files and immediately find everything you did. That takes a systemic thinking. You have to really develop that system and follow it religiously for every project you work with. That would set you apart in data management skill much more so than knowing SQL. I know I pick on those who ask me that question. Please don't take it personally if you're one of these people. The reason why I do so is because this question does indeed come up a lot. What I want to say is that learning SQL is not that difficult. If you can't write a certain piece of code, there's Stack Overflow somewhere where that command is shown. If you messed up on your data file management at one point in time, no SQL I'm gonna help. All right, so what I'm going to move on next is the data management competencies. They are obviously there are many more, but I try to group them into the most important ones. First of all is making sure you know how to work with statistical programs. and what data types are being used by what program in what manner. That's important, so that when you are thinking about your system of data storage, you can create a system that's the most friendly to every single other, well, every single computer program is going to be impossible, but many computer programs, okay? Now, creating data meta files, necessary information to support your data. Develop a system for doing that. Then an ability, and I recommend that you do it through syntax, to add features, to deal with missing data and other problems. The reason why we do this with the syntax is that if we did something programmatically, we can fix it programmatically. If you went and fixed missing data by hand, and then you forgot which row you fixed, you'll never restore that. Okay, and then create data files of different types. That's also exceptionally important. So if you have .dat file, can you transform it into some other type? How easy would it for you to do so? Would you use R? Would you use Python? Would you use standalone software of some kind? So you have to develop the system that makes you the most flexible. Now, these data management competencies are going to set you aside or apart from your competition much more so than SQL programming, because almost anyone nowadays can write SQL as a skill on their resume. Data management competencies, not so much, especially because if a manager who's hiring you is experienced, they will ask you one of these questions and they will know whether you know what you're talking about immediately. All right, now let's talk about raw data and coding. There are lots of data classifications, and I teach a course, Contemporary Data Analysis, where I talk about different ways in which we classify data, and I can immediately think of at least a dozen. Now, there are just about a dozen ways to classify data formats. You can do that data by how easy or how friendly the data are to you. The first type of data are easy data. They're statistically friendly and they can be analyzed with any software. Next on the level is medium, where data are in alternative formats and they require conversion. Now, as I said, even if you have a programmatic conversion, some characters may not convert precisely and you'll end up in trouble. Now, more challenging are data that are embedded. Now, that requires special skill and you have to take a course or two. Like I said, we offer exploratory data analysis that allows you to learn those skills. The most difficult are raw data, where the entry is required. Why I'm saying it's the most difficult, because raw data do not come in easy numbers. They need to be converted. They need to develop a system of entering, including, do you use a comma or do you use a period for decimal separation? Now, if you are in the Western part of the world, you use a period. If you are in Russia, you use a comma. And if you switch between the two worlds, like we do in our lab, because we work in the international community, the same file might contain both, and then you're in trouble, because 3.5 might not be recognized as appropriate data entry point as 3,5, right? Okay. Now, since raw data are the most difficult data, the question is, why do we even use it? Why don't we use data created by someone else? Well, because lots of times, if you, let's say you have your only source is historical artifact that you found, and you can't get it into the system any other way but by coding it yourself, that's the only option you've got, right? Now, for some entry-level people, it requires the least experience. So you can just put some of your interns and tell them what to do with the data and how to process and enter it, and they will do it, especially if they have excellent rules for do that. It's a universal format for most people. They can easily see whether it's text or something else. And then on their quality issues, if something is wrong with data, you can easily see that in the raw data. Once it's processed and put into the database and cleaned up, you automatically assume that all the data points in the same column contain the same information, right? So if you have a variable that's called age, you'll probably think it's age. It's just the number that represent age. The problem is, what if you have people who are older than 1 year, and then you have babies? And the age is not coded as a fractional number, but as number 6. 6 will automatically be assumed as 6 years old, where a baby could be 6 months old, right? So just because something is in the variable form doesn't mean it's correct. With raw data, you would notice those issues. Now, of course, there are some keys to using raw data. You must have a code book. You must check data immediately, because missing data, as you'd have pointed out today, are very real. And then there could be lots of column misspecifications and some other issues. Create syntax whenever possible for creating your data. Use syntax, don't do it manually. Copy pasting columns from one Excel sheet to another is probably fine, but it's very prone to errors. We are humans, we make mistakes. Use label statements that allow you to create computer readable formats. Yes, you can label the variable by yourself on your own with just characters in Excel and then transfer it to R. But you're much more guaranteed that your label will be more accurate and then computer friendly if you do it programmatically. Now, data coding is another special issue. That's data coding is how we take the data around us in the world and turn it into numbers. So, for example, when That American Changing Lives had lots of questions about household. For example, had questions, what type of household activities do you usually do? That's a data set about Americans and how they live their lives. Do they go golfing? Do they go swimming? How often? Do they spend time together? Is a Friday night movie customary? See how many questions? How do you transform them into a data usable format? That's called coding. It's converting from one format to another, and it's prone to lots of errors and lots of inconsistencies. Even when done programmatically, there are lots of people do so by hand. And you need to have a formal scheme. You need to have a format. You need to have rules for exceptions. If you have some kind of a discrepancy between coders, then you need to have a system alert that will tell you that there could be a problem. And you need to enter data into that coding scheme to make sure that you do that you understand your system very well. Okay, so how do you develop that coding skill? Well, I'm going to show you something since I'm talking about that. I suggest that you use a programmatic approach. Now, this is a coding instrument that we have developed in our lab for entering data sets. There are lots of different sheets here that contain data. This is the main one that has all the data information. Now, it was written in Excel Visual Basic for applications. You don't have to use Excel, you can use any other software. If you use your own add-in, here is that add-in plug. And here we have enter data buttons, modify, lookup Oracle info, clear data entry form, create a data set, view existing report, and unprotect sheet, and so on. So this is an actual system of keeping clean data. It was designed to code oracles. And we were working on a project where we needed to extract information from the oracles. So when I open this data entry form, so see how it has oracle title, authors, journal, volume, year, pages, its length, its age, how many references it's cited, the type of, so this is the information that should be entered, right, into the, about the oracle, the metadata, the oracle title, for example. Can you see immediately how many sources of errors you can have? Somebody can mistype an oracle title, and that would generate a problem. So we had to think about the way, as originally it was just a form like this, right? But as we started entering information about authors, about oracle titles, we realized we're human, we make mistakes. So what we did instead is we generated another form where we have, see all of those oracles, We downloaded them from, well, you can download them from Web of Science, Scopus, anywhere, I mean, journal website, where they are given in a certain format, in the same format as they're stored in that journal. And then you can pull it up, or we can just take here's bilateral atomic and get it in. And here it is, everything is populated, right? So we have the volume, year, pages, we have 2 authors. Now we have to manually enter affiliation. And again, so we don't mistype something, the list of affiliations is prepared on a separate data sheet, they're called inputs. And when we find something that's not here, we enter it. And then at the end, of course, there are lots and lots of universities. So if it's not here, you can enter it in, and then everyone will have access to that university. And then the gender, of course, I mean, for atomic, we know that it's a female Adar, we don't know, so we have to look it up, find that person somewhere so we can enter their gender. Now, there are some attributes here that you can code, but again, to make sure that you do not miss, because when you code an article, there are certain set of characteristics that you have to code. Now, if an article is empirical, it will have a different set of items to code than for an article is methodological. So obviously, when you click the empirical type, another framework has appeared that guides you through all of these changes, where you can just click something as opposed to entering the number in Excel. And same with methods, you can just check mark something, right, as opposed to entering it in Excel. You can enter the comments, you can note to code the article by all raters to make sure that if you have something that raises questions, people will notice that, and then you can write down some of the comments you might have. And notice we're going through authors, we're going through attributes, and here are some. We start, of course, with this framework, and then we have methods used, and that's the first time that the enter data button has appeared, because comments, record statistics, well, these ones you can't change. Those are optional, but everything before that is required. So until you enter all the required data, you can't hit that enter data button. This allows us to avoid some of the programmatic data entry for a problem. Or let's say we made a mistake and we want to modify the data. We can pull it by the article ID, or we can pull it by author information. So when I'm modifying the data, all of these numbers, see, there are numbers already here, they entered, and something has already been checked in. So I can just change it right here on this record and then enter it. Okay, so these coding instruments, and you can develop them in any shape or form you might want, they allow you to avoid data entry errors as much as possible. Now, I realize that when entering data into this form, you can easily misclick something. That could happen. But chances of misclicking something are much, much lower than actually missing it and entering it in the wrong column. Notice, by the way, that I can't make any changes. This is my main file with a data set. See, I can't click on this. The data set is protected, so you accidentally don't delete your data. Now, why do you think we've made all of those checks in the system? Because we've made every single error that you could think of when entering data. So we are now protecting ourselves from doing so. So when I said talk about system of creating coding instruments or data management, you have to take lots of things into account. Of course, you are not born with this knowledge. This is systemic knowledge that you have to learn somewhere, and we teach this knowledge in our program. All right, let's return to our presentation. We have a few more minutes left, and I'm going to just talk about a few more things. All right, so the data files and the data cleanup. So we're done with coding, right? So next thing in managing that relationship is data files and data cleanup. First of all, you have to find out, how do your data, how do your statistical packages think about your data? how do they store it? Do they have flat file structure, which is variables by keys? Now, the existence of variables by keys as an observations is a basic requirement of data that you can work with. Until you have that type of structure, you are not able to. Now, most programs operate with flat files, even though hierarchical structures are possible, especially if you have a relational database where data are connected, the fields are connected to each other by primary keys or some other identifying records. Now, of course, you can have, if you have relational files from databases, they need to be merged by that primary key. And working directly with database data is usually very complicated. You have to write queries. That's where you do need SQL. And we do teach that. So SQL does come in handy. Now, some programs allow for creative structures. For example, you can store data in a certain format. One simple data structure they can think of is called PIAC file. That's for the program .page, for the program PIAC that analyzes networks. PIAC files are very storage friendly, because when you have networks, if you store them as a matrix is, nodes by nodes. If you have 15 nodes, that's 15 by 15 matrix. And when there are lots of information missing, if you have zeros there, that still takes up a storage space. PIAC only stores information about the links that are present, which allows you to pack up lots of information into a flat file. Well, but that's a creative file, right? It's one of a kind. It's very unique. It's designed for PIAC only. So then, of course, there are routines that convert it from PIAC to other files. Now, data files determine which statistical program you use. SPSS is not very friendly with its files, so you have to have conversion routines, and of course R can do that, but still you have to be very careful. There could be particular needs at the data entry point, and you may need multiple data files to accomplish an analysis of some kind. Now, another thing I want you to pay attention is the errors of the sources of error. There are 5 main types, starting with conceptual. If you are analyzing data and you realize you have a conceptual problem, it's too late, okay? Conceptual problem is when we design our study, we ask the question and we conceptualize what type of data we are going to use for our analysis. If you made the wrong decision right away, you have to start from scratch. Now, collecting data, entry, recording, and coding, most of them are fixable. Even if you collected data wrong, you could lots of times go back and recollect it again. Now, post-correction errors is the reason why we do backups. I told you about backing everything up multiple times with notes, what's backed up where. That's because we do make post-creation errors. How do you fix errors? The first #1 step when you work with your data file, check the number of observations. How many observations you had, how many observations are being read into the computer format. As a teacher of statistics, I get lots of homeworks. You would not believe how many times my students have complained, I did everything correctly. I have followed every single step. Why didn't you give me a full grade? Because your answer is wrong. And your answer is wrong because when you were reading the data, you didn't realize that you did not read it correctly, and you analyzed the wrong part of data. You didn't analyze the entire data set. And lots of times people think, well, but I did all the routines correctly. You taught me the routines. No, routines is a means to an end. If the end result is wrong, it doesn't matter how you got there. It's wrong. So make sure you start with a number of observations. Then check the number of variables in the data set. Lots of times variables get merged. It's very easy to do for software, especially if the columns not very clearly separated. It's very important when reading into R. R has its own brain when it comes to data reading. Now check for wildcodes, totals, do consistency checks, and check the coding and recoding. Those are the simple sources or simple steps that can tell you something is wrong with my data. I have to go back and fix it. And that's where you start your data relationship. Now, I am done and I am just on time. I'm exactly 1 hour. I'm very happy to answer your questions. But if there is enough interest, we'll talk about, today we just talked about general issues of managing the data relations, just the very, very beginning. If we have enough interest, then I will have a series of webinars and masterclasses about converting data between different formats, getting them in and out of the database with SQL codes, even though I don't like teaching SQL because anyone can teach you SQL. Teaching something that SQL doesn't is a different story. So it's basically, there are lots of things that we can do. Today was just a start. And I am delighted that you were here with me on this lovely Tuesday afternoon. We have a week for you to join us in our master's program, where you can learn this and many other tools. So please feel free to join all of our Telegram chats, write us questions via email or via any other channel, and come to our future webinars. Even if you don't join our program, I would be delighted to share some of our experiences with us. Does one have to prove certain math and statistics knowledge to be eligible? No, we start from scratch. And now this is one of the biggest differences between our program and other programs. We promise to anyone, regardless of their original field of study, that we can teach you to analyze data. We have had people from a variety of fields. Of course, all the OGs, sociology, psychology, political science, and so on. There are lots of people who come from those fields. But then we had some people who came from the fields of linguistics, philology, law, medicine, and some other fields that traditionally are not associated with high data knowledge. And we offer courses on two levels, basic and advanced, where you start from zero. When it's a basic course, you know nothing. We assume you know nothing. We teach you from the very beginning. The learning curve is very steep. And lots of times I say, people ask me lots of questions. They usually don't ask me how difficult it is to study. It is difficult. I never said to anyone, oh, this is easy. We teach you to learn this from scratch, but you don't have to do anything. No, that's not how it works. We teach you from scratch, but you have to do your part. We will offer you lots of tools, lots of instruments, including social support. We are a networks lab, right? We know something about networking, but you have to do your part. We will offer you projects, data, community to work with, other students to struggle and commiserate with. At the end, even the first year, you look back at yourself, you look back at some students who are just entering the program and you think of them, oh, juniors, what do they know? You learn so much. This is one thing that's universally applicable to every single student we've had. Every student has always said, I've learned a lot. I've never had a student who said, oh, well, this is wasted 2 years, I knew it all. That happens with the master's programs, especially if you have a bachelor's in one discipline and a master's in the same. Lots of times master program repeats what the bachelor's does. Even if you come from a field of statistics, I promise you, you will not repeat what you have learned in statistics, because you most likely had mathematical statistics. You know how to prove central limit theorem. We'll teach you how to use it. And that's a very different skill. So thank you for being here, and we'll be delighted to see you at our future webinars. Next week, in fact, we'll give you a chance to talk to our students and alumni who can tell you from their views and their standpoint what our programs are all about. So thank you for being here, and everyone have a good night.